Hey guys, so in this video here, we're going to do a couple of different things. First of all, I'm going to walk you through an experiment was being done. We're still studying plants. Now, yesterday we learned that plants need carbon dioxide to be able to gain mass. But we also need to find out what leaves a plant as it goes through this process called photosynthesis. So that's what we're going to look at today, and we're going to see if we can figure out what gas is leaving and what influences how quickly that gas leaves. So to start us off, we're going to go here into a video, and I'm going to kind of dictate some things with this video. So this is an experiment we would have done in class where they took an aquatic plant called Elodea, and they're going to then submerge it in water, and then this plant is going to produce bubbles, which they then capture in this test tube. Okay, now we want to know, what type of gas this is that's being produced, and like I said, in a minute we're going to look at what influences the rate of production of that gas that is being produced. Okay, so we see these bubbles being produced. Now let's pause. What we need to do to be able to figure out what gas this is, one of the tests they're going to do is they're going to test whether or not this gas is flammable. Okay, flammable means it does burn, non-flammable means it does not burn. So they're going to put this match towards it. If the match flares, the fire gets bigger, means the gas is flammable. If the fire gets smaller, it means it is non-flammable. Okay? Now, let's see what happens. They take the lid off the test tube and look at that, the flame expanded. So that means that this gas, whatever it is flammable. Okay, what I want you to do now is give me your best guesses. What do you think this gas was? Okay, now, let's see, we've got to sign in here. This is another, not sign up, sign in. This is another experiment that is on this Gizmos, but this time instead of having you guys do the experiment, we're just going to I'll do it together and kind of learn a little bit here. Now, hopefully most of you guys guessed that plants produce oxygen. Now, you've probably heard that before, that plants produce oxygen so that we can breathe. Now, what we want to know now is what influences how quickly that gas is being produced. So what we're doing is we've got this pond here. We've got a thermometer. We know that the pond is 29 degrees Celsius, and then this is an oxygen reader. So we're saying that there is 4.04 parts per million, that's ppm, parts per million of oxygen in this water. Now, I'm going to hit play, and when I do, time will begin to progress. Right now it's reading 6 a.m. Now, as time progresses, the day is going to get warmer. That means that the sun is shining brighter on the lake, and that's why we have the thermometers, to verify that the temperature is increasing. Also watch what happens to the amount of oxygen as this progresses as well. So time's passing here. We're almost to 7 o'clock, and we see that our oxygen is actually increasing a little bit, and it's beginning to go faster and faster as it increases. We're now at 8 o'clock. Our temperature is now increased to 30 degrees. You should be able to see that there, okay? Our oxygen still increasing, going faster and faster here. We're almost to noon. Okay, now a lot of times we think of noon as the hottest time of the day. It's normally not the hottest time of the day. Normally the early afternoon is hotter before it begins to cool down. Still, we see the amount of oxygen here still rising. Okay, we're to 3 o'clock. We're at 6 parts per million. Temperature's at 33 degrees. Okay, so we see that the sun's intensity is definitely increasing. Oh, it's slowing down. Let's see what is its highest point. Oh, it's now nighttime. Okay, the highest temperature we reached was 33 degrees, and the highest oxygen level was 6.43 parts per million, meaning that as the sun was up, the the oxygen level was increasing. Now let's see what happens at nighttime without the sun. Notice that already we see that our oxygen levels are going down. Now, you might be wondering, why are we measuring water for oxygen levels? Well, if you notice, even in this drawing here, there are plants around and there would be plants within the water, meaning that those plants are producing oxygen. This is just a convenient way to try and measure how much oxygen is within that environment. Okay, we're past midnight here. We see that our oxygen levels are still decreasing and our temperature is still decreasing as well. Okay, so what we need to know is what is needed in order for, or what influences how quickly the oxygen is being produced by these plants. Okay, we're now to 4.06. See how low it gets. 4.04. And that was our lowest point, 4.04 down to 29 degrees. So we're now starting over. Okay, so hopefully we've given you enough information. You've been able to answer all of these little quiz questions. If you have any questions or problems with this, shoot me an email.